Wireshark can't do its job by itself. It needs another tool, and that tool is called WinPCap. It's a packet capturing monitoring tool. So you've got some layers here, and take a look at these layers before we talk about the diagram down below. So at the bottom here we have network card drivers. That has to be installed by the operating system. That has to work. That could be Ethernet or it could be Wi-Fi. It doesn't matter. And then above that you've got this abstraction of the operating system, Windows versus Linux. And Windows and Linux treat it very, very differently. Then what you have is an open source library for packet captures, that's WinPCap, that tells the operating system, give me all this data. And then Wireshark is the application for actually examining this data as it's flowed up to that level. If you don't have a network card, you can't sniff packets. If you've got a network card in an operating system that won't allow you to go into promiscuous mode and it does something else called monitor mode, can't sniff packets. If you don't have WinPCap, you can't capture those libraries. You can't capture that information in a meaningful way to present to the application layer. Now down below in the diagram what you see is you've got a packet analyzer, that's Wireshark, that could be anything. Below that you've got the packet capturing tool, the PCAP down below, and that's inside the green box and inside the blue box. That gives you a copy of all Ethernet frames from the network operating system. So you're convincing the operating system in something for Windows, it's called TCP sys, I think. You're convincing it to give you a copy of these frames because it normally wouldn't do that. It would say, okay, you need an application here to do this. You're intercepting that instead of going up to the regular browser. You're intercepting those copies of packets and you're flowing them a different way. So you need Wireshark and WinPCap together to make this work. Let's look inside the Wireshark interface. So when you first launch Wireshark, you won't see any of this, but I wanted to give you an idea of what the interface looks like. At the top, you've got the command menus. You have a blank white box, which is the display filter. We're going to learn a lot about filters, and you need to know how to write filters. Then you've actually got the listing of each one of the packets in that next piece down. There's this kind of 3 layers of looking. That first is all of the packets. The second is one of those packets that's highlighted in the listing packet captures area is then detailed in the details section, and you can click plus and minus on each one of those pieces of the packet itself to examine the details. Down below that is the ASCII and the raw hex. So if we need to go to the hex, we can. It's right here in front of us. That's your basic layout of Wireshark. So how do you make this thing work? Well, first it looks like this blank screen. It's like, there's nothing good for me there. What's going on here? So the first thing you do is you say, okay, I need to capture and I need to set up an interface. So you click on capture and interface, and then it pops up a dialog box like this. You're going to choose a network interface. By the way, looking at this, you'll see that I have 5 interfaces. What you want to do is when you're looking at these interfaces, you go, which one should I choose? So look at the one highlighted in red. And you'll see that it says the wireless Wi-Fi link 4965 AGN, Microsoft Packet Scheduler. And then it says the IP address. But then I want you to look over in that third column. See where it says packets? And you'll notice if you really squint, it's not lit up at this point, but it says 5. All the other ones say 0, and that one says 5. That's the one you want to capture because it's showing you packets. So if you just wait a couple of seconds, you'll see some packet information flowing across, and you'll see that increment, that counter increment. If you don't see anything incrementing at that point, open up a command prompt, ping your local DNS server or your router, and then packets will flow, and you'll see them pop up inside that little piece right there so that you can figure out which interface to choose first. If you're doing this with virtualization, as a penetration tester, remember I said we are going to capture all of our traffic in and out so that we can prove our activity. If that's the case, then you may be doing the virtual VMware adapters. Depending on your operating system, the operating system may stop you from doing that or may ask you Do you really want to turn this particular virtual network card into promiscuous mode? Are we allowed to do that? Again, it depends on your operating system. So now you've got 3 buttons there. We're going to focus in on this. So you've got Start, Options, and Details. So we're going to click on the Options button at this point. It pops up the interface for us here. These are your configuration options that you need to pay attention to if you're doing this for a living. If you're just taking a peek and you're playing with Wireshark and you're doing it in your labs, no big deal. But if you don't know how to configure the capture options for your interface in Wireshark, you're going to run into some problems. So first, interface IP address, those things, they're just fine. Buffer size is not a big deal for most of us unless you're on a multi-gigabit backbone. Then you've got some problems with buffering. You can do a capture filter. That means that you will differentiate the packets that are flowing and not take all packets. If you put in a capture filter and you say, well, I want to see more information about the other conversations that were going on at that time, it's too late. You want to apply capture filters very sparingly. The reason why you would do a capture filter is because you know the source and destination of your transmission that you're interested in, and it's a really busy network, and you don't want all that other data. You want to discard that because, remember, you're storing all these packets, and these could get relatively large quick, especially on a busy network of a real enterprise. Notice below we've got capture files. So under the capture filter we've got capture files, and you can configure the capture files to split into little intervals. You can also say to start captures at a particular time based on a particular amount of data that is flowing. And then you've got all your display options. Now here's the thing with display options. Busy network. It says update list of packets in real time. In a busy network, if you allow those packets to flow right there and actually examine them, you will overwhelm your Wireshark interface. So what I suggest you do is, if you know what you're doing, deselect that checkbox and then start your capture and let it run. When you're finished, you can go in and examine your packets, and you don't have to worry about the memory being chewed up by the application trying to keep up with the packets that are flowing. Again, if you're playing around, turn it on. If you're not playing around and you know for real I want to capture these packets and I'm not going to look at them until afterward, then turn it off and your machine will run a lot smoother. So now, let's look at an interface where we've got lots and lots of data in it. Up above, what you see is you see color coding for the original list of packets that are there. And then you see a detailed conversation down below in green. That means that it's actually working. And then remember, in the middle there, you've got the expansion buttons. On the left-hand side, you've got the plus and minuses so that you can dig down into more details as you need them. The final pane down below may give you a hint to what's going on. Now, if you squint right now and you look in the blue area at the bottom, what you'll see is in the ASCII decode, you will see that this is a web conversation, and you can tell because it says Gecko Firefox. So you know a lot about the conversation that's going on between these two hosts based on looking at the actual ASCII. Now, if you went up a pane, you would see that it's Ethernet, Internet Transmission Control Protocol, and then it says Hypertext Transfer Protocol. So you could look there and see that you're having an HTTP conversation. If you went up to the pane above, you would also look at the ports that it was using, and that might give you a hint as to an HTTP conversation, or you can actually see on packet 224 that it's actually an HTTP conversation that got set up in the original communications there. Okay, so packet 215 is an HTTP packet. We know that's an HTTP conversation. Then you've got the details of this selected packet and then the raw packet information. So we clicked on that one, packet 215, then we looked at the details, and then we can look at the raw information. We can filter this conversation as it flows and say, just show me inside of this interface only HTTP traffic. How you write that filter is you type in HTTP. Boom. you're done. You have filtered at that moment in time. We're going to look more at filtering options and capturing options in just a minute.